Hey everyone, so since we're not Zooming today, Thursday, I told you guys I would post a video for those of you that regularly attend Zoom. So here it is. All right, so review 3 has 25 questions, a little bit longer, but most of it's on triangle stuff. So let's take a look. All right, name the postulate, if possible, that makes the triangles congruent. So remember, there are 5 ways to prove triangles congruent. Okay, and again, if you need to, look on your study guide. Side, 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 angle, side, angle, side, angle, 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 side, and if it's a right triangle, HL. Remember, HL only works with a right triangle. So glancing at this right off the bat, I look at my answer choices, okay, and I notice what they're trying to show you here, and it looks a little weird, is that this angle right here is 90 and this angle right here is 90. So hopefully you recognize that that is a pair of angles that are congruent. And then they also give you this congruent to this, so that's a pair of sides. And remember when we did these, I said label your parts A for angle, S for sides. So right now we have AS. Okay, and we know that's not a choice, but remember, there are 2 things you need to mark that they're not going to mark for you: vertical angles and shared sides. So I got to mark those vertical angles. When I do that, that's another pair of congruent angles. So my triangles are congruent by angle, side, angle. Not going to do number 2, but again, make sure before you make any choices, this side is in both your triangles. You need to mark it congruent to itself and consider it a possibility, okay, before you choose your answer. All right, number 5. Okay. Number 5, they want you to do a reflection. Okay. Reflect 6, -3 over the line y equals -x. Okay. And you will have graph paper, and you could try to do this on the graph paper if you wanted to, but faster to do it on your Desmos. Okay. So what I would do to put this into Desmos is put in the point. Now remember, don't use X and Y if you're putting in ordered pairs. I'm going to use A, and it is 6, -3. It's just the ordered pair they gave me. And look, Desmos will graph it for me. Then I'm going to also graph the line y equals -x. Okay, because that's going to show me what I need to reflect or flip over. Now, if this was a do-it-yourselfer, that would be a little bit more challenging. But this is a multiple choice. Okay, and I'm actually going to come up here, and I'll show you why in a second. I'm going to change this from A to, I don't know, T. Okay, where's T? There it is. All right, I'll show you why in a second. All right, it doesn't really make a difference. It's still in the same place. So since this is multiple choice, you can do this on Desmos. So I'm going to answer choice A. Here's why. I'm going to type in the ordered pair for answer choice A. Answer choice A says 6, 3. Okay, now I'm going to ask myself, is this blue point, is that a reflection of my black point over my red line? Okay, and the answer to that is no. Okay, the blue point is not a reflection. So then I'm going to try answer choice B. And you can leave point A up there, or you can delete out if it bothers you. So I type in -6, -3. Okay. Is the green point the reflection of the black point? Okay. And the answer to that would be no. Then we try C. Answer choice C says -3, +6. Okay, that happens to be purple. So clearly purple is not a reflection, because remember, reflection means it comes across. It's like it jumps over. And just so I don't have too many dots all over my picture, I'm going to go ahead and use take C off and do D. Answer choice D is 3, -6. 3. Don't forget your comma in your ordered pair. Okay, now, if you look at that purple dot, that is the reflection of the black dot. Remember, reflection, if you were to imagine the paper folding on the line of reflection, okay, so if we folded the paper on the red line, then those two would be reflections of each other. Okay, so since it's multiple choice, you can use Desmos. Okay. Use Desmos whenever you can. We cannot use it as much as we can use it in algebra, but we certainly can use it. Okay, so 3, -6 is my reflection. Okay, so again, if you're doing this, you're not going to have it. It's not going to be answer choice D for you, quite possibly. So look for 3, -6. All right, just to save you a little time, the answer, I'm just going to give you the answer to number 6. Okay, the answer is 72. Remember, you find the surface area of both, add them together. Number 7, again, find the surface area of the pyramid, find the surface area of that's a rectangular prism. Okay, it's a square prism, but you just use the rectangular prism formula. Add them together. We did one like that yesterday in Zoom where we had a cone and a cylinder. Same idea. All right, let's look at number 9 because we really didn't talk too much about this. These aren't hard, but you kind of have to see them. 2 spheres, so like basketballs, have a scale factor ratio of 1 to 3. So remember, ratio is a fancy word for fraction. The smaller sphere has a surface area of 16 feet squared. Find the surface area of the larger sphere. Okay, here's how you do this. This is a proportion problem. And remember when we did similar triangles, we did a lot with proportions, making sure our sides were proportional. Same thing here. Here's how you set this up. You do have to pay attention to what they're telling you they're looking for. So they're looking for surface area. Remember, surface area, we always square our units. Okay, so when they give us a scale factor of 1 to 3, if we're going to go after surface area, what we're going to do is we're going to square our scale factor ratio. Now, if they had said, what's the volume? Volume, remember, our units are always cubed, so then we would have done to the 3rd power. And then we're just going to set a proportion. Okay, the smaller sphere has a surface area of 16 feet squared. Well, out of 1 and 3, which one's your smaller number? Clearly 1. So you're going to put 16 on the top of the fraction. And so that means the larger sphere would pair up with the larger number, and you can call it X, Y, P, whatever you want to do. Okay, and then now it's just algebra. Again, if you're really not good at the algebra, jump on over to Desmos. You just got to be careful and cautious how you type it in. Do your fraction, do 1 squared over 3 squared, and it looks weird, but that's okay, equals, do your fraction again, 16 And notice, because some of you are like, I don't see anything. Okay, remember, when you do this, you're looking for the graph. And when I first started out, I don't see any graph. And so you just got to zoom out. Oh, still don't see it. Just got to zoom out. Keep on zooming. Oh, I finally found it. It's way over here. It's a pretty large number, so it's going to take you a minute to get there. Remember, just, oh, if it lets me, it may not let me. Oh, it's not going to let me. All right, so, well, if we zoom in, we'll be able to see. There we go. Usually we can click on it, and it will tell us, but it wouldn't tell us for whatever reason, probably because of the fraction. So keep on zooming in until you get the number. Ta-da, look. That would be what? Yeah, 144. So that's your answer. Now, could you have done the algebra? Sure. Should you be able to do the algebra? Yes. Okay. You would have just squared your numbers, which would have been 1 over 9. And cross multiplied, 1 times x is 1x, 9 times 16, 144. And some of you might say, oh, hold on, technical issues. Some of you might say, well, the algebra is faster than the Desmos. Well, then do the algebra. I tend to agree with you on some occasions. It's faster just to do the algebra, but okay, it's there and for you to use it, and if you don't want to use it, at least use it to check yourself. All right, same thing happens here. Okay, except you don't have to set up on number 10. Okay, 2 similar pyramids. So as soon as you see that similar, whatever they're talking about, triangles, spheres, pyramids, okay, the word proportion should come into your brain. So they're telling you they have heights of 4 and 7. Okay, they just want to know what's the ratio, again, fancy word for fraction, of the volume of the small to large pyramid. Okay, so when they say small to large, they want the small number on top, the bigger number on bottom. They're telling you that the heights are 4 to 7. Volume, what did we say about volume? Your units are always cubed. So all you'd have to do here, you wouldn't even have to write an equation. You would just have to say 4 to the third, 7 to the third. Okay, now notice they didn't write them as a fraction. They wrote them as a ratio. Okay, that's another way you can write that with the dot, dot. So you just do the math. 4 cubed, it's 4 times 4 times 4. 7 cubed, it's 7 times 7 times 7. Okay, so 64 to or over 343. Number 11, they like to do this, and people always think they can't do these, but this is a proportion problem once you set it up. A power pole, there's my power pole, 10 meters tall, cast a shadow, remember shadows go across the ground, 8 meters long. At the same time that a building nearby, and so here's my building, cast a shadow 14 meters long. How tall is the building? So, I don't know. What people don't realize is these are just triangles, and you can make them similar and do proportions. Okay. So, I don't know the height, so remember, call it whatever you want. So, I'm going to do the height of the building over the height of the pole. Okay, and again, if you wanted to start with something different, you could. You just have to stay consistent. Since I started with the building on top of my fraction, I have to come back to the building, and that number needs to go on top. You have to stay consistent with that. And that'd be 14 over, that matches up with 8. Now again, if you're not good with the algebras, type it into Desmos, find where your line crosses your x-axis, but really you're just cross multiplying. 8 times x, 10 times 14, divide by 8, and that gives me what? 1, 14 minus 8, 6, right? So 60... that'd be 17, be 56 with a 4, 17.5. Sorry, that took me too long. Okay, so the building is 17.5. So, do not think you can't do them. Draw yourself a picture. Okay. Anytime they start talking about poles and shadows and blah, 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 it's a proportion problem. Similar triangle problem. All right, this page here talks about similar triangles. I'm not going to do any of these. Just remember, if you're going to do anything with the side, you got to set up a proportion and check. Remember, there's only 3 ways to prove triangles similar: side, 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 side angle, side, or angle, angle. Okay, if you need to, go look at your study guide. you forget those three. But again, before you say side, 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 set up your sides, make sure they're proportional. All right, same thing, more similar triangles. Now, these are proofs, and we did not have time to really get into these. So for now, I'm just going to give you guys the answers. Okay, if you run into that, if you are taking the SOL, you should only see one. Just make an educated guess and move on. Again, with us doing virtual, hybrid, and then virtual, we just did not have the time to cover everything. So let's take a look at a trig problem or two, because some people asked about that. So let's look at number 20. They just want to know the correct setup. Now, on the SOL, if you're taking it, they'll probably want you actually to solve this out. They might say, hey, find X. So we'll solve it out just to make sure that you remember how to do it. So remember, when you do trig, it's SOHCAHTOA. Okay. And they do have a picture for you of this on the formula sheet. It looks a little different. Okay, they give you a picture, and then they have the S, the O, the A, just like I do. It doesn't look quite exactly the same. But remember, that means sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So remember, first thing you do is you come over to the angle. Sometimes it'll have a number in it, sometimes it'll have a variable or the theta symbol. Okay, that's your reference angle. You mark it. Now you label the sides in relationship to the angle. So I look and I go, okay, well, this X is across from my angle. So remember, that's opposite. The 12 is next to my angle, so that's adjacent. This side right here doesn't have anything on it, so I'm not going to label it. Okay, but hopefully you see, just so people, that's your hypotenuse. Okay, because remember, it's either opposite, adjacent, or hypotenuse. That's the only three choices you got, and there is only one of each. Okay, so just wanted to point that out. I'm not going to label that because it's not going to help me with my problem. So I have opposite and adjacent. Okay, O and A, that would be my tangent. That's the TOA. So to write this, you would say tangent. What's the angle? What's my reference angle? 24 equals, okay, it says opposite. What did I label as opposite? X. Over adjacent. What did I label adjacent? Now, we actually do need to solve this. Okay. We do need to put this into the calculator. Fastest way you can do this is cross multiply. Okay. I don't think I showed you this when we originally did it, but I'm going to show it to you now. 1 times x is x. Okay, this becomes, and write it this way, because if you don't write it this way, when you type it into Desmos, it's going to mess you up. 12 times the tangent of 24. Okay. Now you're going to jump over to Desmos and clear this out. Hit this. And you're just going to type in 12 times. Now remember to get, oh, not double times. To get to your trig functions, hit this. Okay. Tangent 24. Now, notice there's an issue here, right? It says negative. Can you have a negative side measure? What that tells me is I don't have it in degrees. So remember, come over, hit your little wrench up here at the top, okay, and see how it's highlighted, and down here at the bottom it says radians. I don't want radians. I need degrees. Now it looks a whole lot better. Okay, so when you do this, make sure you hit your wrench. Okay, if you're doing sine, cosine, tangent, and hit degrees. because a lot of times it's not going to be in there, and I'm glad that happened so you could see it. At least I realized, hey, I'm looking for a side. It's not going to be negative, so something is either wrong, or I always check to see if I'm in the right mode first. Okay. Now, on that question, they actually didn't ask me to go that far, but I wanted just to show you. The answer would be tangent 24 equals x over 12. Okay, and if they actually wanted me to work it through, then I would say x is 5.3. Okay, so this side is 5.3. They didn't tell me units. All right, let's look at when they want you to find an angle with trig. Okay, so just so you know, just so you see this right here, that theta is your reference angle. And remember, we talked about it. We didn't use it a lot, but I said that's just like putting a question mark or just like putting in x. And so, well, actually, let's already do this one since I marked it. So find the measure of the reference for the reference angle. All right, so it's a right triangle. Remember, right triangle, it's either Pythagorean theorem or trig. When you're looking for an angle, it's trig. Okay. When you're looking for an angle, it has to be sine, cosine, or tangent. You can't do Pythagorean theorem with an angle measure. Or if they give you an angle measure, that's how you know it's trig. Okay. Pythagorean theorem, you're only going to have sides. That's the only thing they're going to give you, side measurements, and ask you to find a side measurement. So we do the same thing here. We mark our angle. We label our sides. So I go, hey, the 17 is the hypotenuse. The 12 is next to my angle, so that's adjacent. I'm not going to label this side over here because there's nothing on it. That would be my opposite side, but I don't need it, so I don't want to confuse myself. So I have adjacent and I have hypotenuse. That is an A and an H. That's my ka in my mnemonic, SOHCAHTOA. So that's cosine. What's my angle? I don't know. Okay, we'll call it theta. If you don't like that, call it x. Equals, okay, cosine is adjacent over hypotenuse. So what did I label adjacent? 12. What did I label hypotenuse? 17. Now, once you write this, you have to go to Desmos. There's no other way to solve this. Okay, there's no algebra you can do or anything. You have to use your calculator. And it's a little different. You got to make sure you know what button to push. So we're going to go to Desmos. Double check and make sure I'm still in degrees. I am, so I'm good. Now, you hit the functions button. This time, don't hit cosine. Don't hit that button. Okay, that's the button you hit if you know the number for your angle. Okay, like if it's like cosine 30, or like the one we just did, it was tangent 24. We don't know the angle, okay? We're looking for the angle, so you have to use what they call the inverse trig function, which is cosine to the negative 1. That is going to let you get the answer that you need. Now, it's weird because normally we always type everything directly in the way that we wrote it down on our paper. So if you go back over here, normally we'd put type that in. Not this case. This is one of the few cases that you don't. You're going to hit cosine, looks like to the negative 1, but it's called inverse cosine, and then you're going to type in your fraction, okay, which was 12, oops, hold on, back up. I got to go back into, there we go, 12 over 17. And again, you can close the parentheses. Desmos does not care if you don't. It will still calculate it correctly. So we just figured out that our angle is 45 that would round to 1. So our angle is 45.1 degrees. And the only way I could get there is to type it into Desmos. So again, once you set this up and you're looking for an angle, you go to Desmos, but you look for the way you type it in. You don't type it in the way you wrote it on your paper. You hit your function key, find your inverse cosine, which looks like this. That's what will pop up on Desmos with the parentheses. Then you just do 12 over 17. Don't try to put your equal sign in or the theta or the x or whatever variable you're using. This is what you want to type in. Cosine, that's what it should look like in Desmos. And then Desmos will give you the answer. So, hopefully that's a help to you. Again, we'll have one more class soon before the SOL, and it's open to anybody. You're welcome to come. We'll talk about any questions that you have. But just let me know if you have any other questions. All right. Thanks so much. Bye.